Welcome back. This is Mr. Hassan's Maths channel. I'm now going to be going through questions from this paper, which is the June 2024 International A-Level Edexcel Statistics S1 paper. I'm going to go through each question, separate video for each question. I'm going to save those videos in a playlist, one for the paper and another for the topic that it comes from, which will help me build up topic-wise and also paper-wise playlists, which hopefully will be of benefit for the students. And also, what I'm going to do is I'm going to try to explain things in maybe some detail in certain parts so that I can address certain issues that I know exist amongst my students, or I've noticed students had issues with. So I'm going to try to go through those. I might take a bit longer than you might expect me to answer certain questions because I'm going to go through some foundation or some background first. It's not like I'm answering the questions at the same pace that you should do in an exam. These are meant as like videos to help me in it's like a teaching material for me to help my students. So basically that's a little introduction to make sure you know what you are in for when you start watching these videos. Okay, now we're going to start with question number 1. It says a researcher is investigating the growth of two types of tree, birch and maple. The height to the nearest centimeter. So we have height, which is a continuous, it's like continuous data, which must be rounded. It's not counted, it's measured and it's rounded. But it's been rounded to the nearest centimeter. So the data, because it's been rounded to the nearest centimeter, takes on a look of being data which is like discrete data. Okay, we can treat it in this sense like discrete data. Okay, it's not like grouped or anything like that. Now, a seedling grows in 1 year, is recorded for 30. So the height to the nearest centimeters that a seedling grows in 1 year is recorded for 35 birch trees and 32 maple trees. Okay, so you have, just to write that down, you have 35 birch trees. So the total here is 35 of the number of trees here, and the total here is 32 for the maple trees. That's the total. The results are summarized in the back-to-back stem and leaf diagram. So this is called a back-to-back stem and leaf diagram. So basically, a back-to-back stem and leaf diagram shows data for two different things. So here we've got data for the maple trees and also for the birch trees. And they are back-to-back, and they gave us the key. Now the key will help us determine what these numbers actually mean. So you see, you've got this part of the data. This is called the stem, okay, which is represented by this thing in between the two lines, the stem. All right, and if we see here, it says 5/63 means 65 for the birch trees, 65 for the birch trees, and 63 for the maple tree. Okay, so this represents the date, the particular piece of data, 65 for the birch and 63 for the maple tree. So we can determine from that the stem is representing the tens. The unit of the stem is tens, and the unit of the leaf, which is this section in these parts here, these are the units. So these represent the units, these represent the tens. So for example, this represents the number 39, not just 939. This represents the number 35, and so on. Okay, so that's the key. So we understand exactly how to read the numbers from the table. Okay. Now it says the median height that the maple trees grow in 1 year is 45 centimeters. Find the value of K used in the stem and leaf diagram. So now the median height is that height which is right in the middle of the data. So the maple trees, we have to concentrate on this. The maple trees, the median height is 45 centimeters. And we have to use that information to find the value of K. So the median height, which is given the name, the median, is given the symbol or the notation Q2, the second quarter, the one that's right in the middle. Okay, so the median. Its position, the position of the median, okay, its position is given by, well, there's different methods that you can use. I'm going to stick to the method used in the S1 textbook, and the one that I find is generally easier for most cases. So when you have this type of data, which is like not grouped data, to find the position of the median, you take n divided by 2, so the number of entries divided by 2, which in this case for the maple trees is 32 divided by 2. 32 divided by 2, which gives you 16. Okay, so now what do we do with that 16? 32 divided by 2 gives you 16. Now, if you use n over 2, okay, then the 16, if the number comes out as a whole number, then we find the 16th and the 17th term, and we find what's the average between the two. Okay, what's in the middle of those two? Because whenever you have an even number of entries, there's always going to be there's going to be two numbers in the middle. Now, for example, if I have like, say, 5 entries, there's just one number in the middle. That's the median, but that's where the median is. But if I have 6 numbers, then these two are the numbers in the middle, the median, and what's halfway between them is the median term. Okay, so here we have an even number of entries, so we're going to definitely have two numbers in the middle. Now, the 16th and the 17th term. So what is the 16th term? So you have 5 numbers here, and then you have another 7 numbers, that's 12, and then you have another 6 numbers, that's 18. So that's the 18th number. So these two are the 16th and the 17th numbers. These two are the 16th and the 17th numbers. So the 16th number is, now, here it says K. What does that mean? 40 plus K, 40 something. 40 whatever this number is. Okay, so what I'm going to do is I'm going to say, let X be the number 40 plus K. Okay, 40 plus K, let X be that number. And so that's the 16th term. So that's going to be X. And the 17th term is 47. That number represents 47. This is 40 plus whatever that is, and that's 47. All right, so now we can see that we've got to find what's halfway between them. We know that Q2 is equal to, as I told us, 45. The value of Q2 is 45. So I know that when I add X plus 47, and I divide by 2, I'm going to get 45. Okay, so X plus 47 is equal to 90. So therefore, X is equal to, that's going to be 43. 90 minus 47. So if X is equal to 43, you have 43 is equal to 40 plus K. So K must, of course, be 3. So K is equal to 3. Okay, if X is 43, if this number, the number in this place is 43, then K must be 3. Okay, because this number represents the number 43. So K is 3. All right, so if you can check your answer, 43 plus 47 is going to give you 90. 90 divided by 2 is 45. So you know that we've got the correct number. So there's your answers for part A. And now for part B, it says, find the lower quartile and the upper quartile of the height grown in 1 year for these birch trees. So we got to look at the birch trees, which are the ones on this side now. So now we're going to focus on the birch trees. So let me just get rid of this and put this over here so that we know we're looking at the birch trees. So we got to find the lower quartile and the upper quartile. So the lower quartile is the number which is 1/4 in when they are arranged in order of size. Just like the median when they're arranged in order of size. These are all arranged in order of size, as we can see. 28, 29, 31, 31, 33, 35, and so on. So the lower quartile, okay, the lower quartile is basically, it's given the symbol Q1, the first quartile. And its position is given by n over 4. Its position, not its value, its position. So that's going to be, in terms of the birch trees, we have a total number of 35. So that's going to be 35 over 4. And that will give us where it is. Okay, so 35 divided by 4 as a decimal is 8.75. So we've got to look for, now if the number comes out as a decimal, you always round up to the next number. Even if it's less than 5 here, you round up. So 8.75 telling us to look at the 9th term. So there's one position, which is the median or the lower quartile position. So the value of Q1, therefore, is going to be equal to the 9th entry. So here we have 2 entries. That's the 10th entry up to here. So the 9th entry is this one. So this is the 9th entry, which is 39. 39. Okay, so Q1 is equal to 39. Okay, and we want the upper quartile, which is given the symbol Q3. And again, its position is given by 3n over 4, which is like 3 times 35 over 4, which is basically 3 times this number that we got earlier. Okay, so it's 3 times the number there. So it takes this number 8.75 multiplied by 3. That gives you 105 over 4, which is 26.25. So as I said, you always round up to the next entry. That's the 27th term. Now there are other ways of doing this, by the way, which you'll find many people do it other ways, but I'm sticking to this particular way. There's other ways you n plus 1 over 4, 3n plus 1 over 4, and there's different ways that you can do it. But this is by far the easiest way, and this is perfectly acceptable in this examining board, and it's, you know, absolutely fine, no problem whatsoever. Just makes life easy for us. So the 27th term will give us Q3. So here we have 2 entries plus 8, which is 10 entries, plus 9, which is 19 entries, plus 9, which is 28 entries. Okay, so we got to the 28th entry. We're looking for the 27th entry, which is 57. Okay, so the 27th entry is 57. Okay, because by there we got to the 28th, that's the 27th. So that's going to be 57. So Q3 is equal to 57. Right, so we have the answers here for this part of the question. That's part B done. And then it says for part C, the researcher defines an outlier as an observation that is greater than Q3 plus 1.5 times the interquartile range. This is actually the interquartile range, Q3 minus Q1, and or less than Q1 minus 1.5 times the interquartile range. Okay, show that there's only one outlier amongst the birch trees. So we got to think about the birch trees, and we have the information that we need here from the birch trees. That's what we need. So we can say that the lower, let's start with what they said, higher. So let's say the higher limit for the outliers. Now an outlier is a value that is so far removed or far away from the rest of the data, it's considered something that we can ignore, right? So in this case, we're trying to find out, are there any outliers, if this is the definition of what an outlier is. So if you look at the higher end of the outliers, anything that's out too high, you know, to be within the normal data, the higher outlier limit can be given by this. This tells you the limit of where, you know, anything higher than the value that this gives is going to be an outlier. So we have Q3, which we know is 57, plus 1.5 times the interquartile range, which is 57 minus 39. Okay, and that will give you the higher one. And the lower one, I'll just get it ready so we can write it down in the end. Lower one is Q1, which is the lower quartile. So anything lower than 1.5 times the interquartile range less than the lower quartile is considered as a outlier. And these formulas, if they give you some definition of an outlier, they will always be given to you, what you have to use. You won't have to memorize those. So now we got 57 plus 1.5 times 57 minus 39. And that gives us 84. So anything that's larger than 84 would be considered an outlier. And then you have, it's going to be changes to minus. You have 39 minus 1.5 times 57 minus 39. That gives you 12. So the lowest limit is 12 and the highest limit is 84. So we can see here we're looking at the birch trees. The highest value is 85. That's outside our limit. The lowest value is 28. So that's within our limit. So we can see that the lowest value is 28. Okay, so the lowest value, 28, is greater than 12. Therefore, okay, that is no outliers. Sorry, the lowest value. Therefore, no outliers on the lower end. Okay, but for the upper end, we can see that 84 is less than, okay, 85. Or we can say 85 is greater than 84. For the upper end, 85 is greater than 84. 85 is outside of our outlier limit. Therefore, 85 is the only outlier. Okay, so that's how we determine that this is the outlier. So now we have that information. Going on to part D of the question, it says here, the grid on page 3, which we're on now, shows a box plot for the heights that the maple trees grow in 1 year. So this is for the maple trees. Okay, so they've already drawn the box plot for it. Okay, And it says, on the same grid, draw a box plot for the heights that the birch trees grow in 1 year. So a box plot is made up of different important kind of values. So you have the lowest value. This is the lowest value. You have the lower quartile, Q1. You have the median, Q2. You have the upper quartile, Q3. And here you have the highest value. Right? So the box is made up of from the lower quartile to the upper quartile, interquartile range. And the whisker part is made up of a line joining from the upper quartile to the highest value, lower quartile to the lowest value. And if there's any outliers, they are marked outside these things. Sometimes this line will take you to the limit for the outliers. And in this case, I think that if we look at this, it has taken us from 25 to 80. In this case, what they've drawn is not to the limits of the outliers, but to the actual lowest and highest values. Sometimes a box plot can go up to the limit for the outliers. Sometimes it takes you to the lowest value and the highest value, and then they mark outliers with like crosses outside of that. The particular example they've given us here, they've taken us to the limit, or not to the limit of the outliers. They've taken us to the lowest value in the data. Okay, so that's what they've done here. So we're going to follow the same format now for the birch trees. So you can see they've given it's like 2 of these squares as your box. I'll do the same thing. Maybe I'll start over here. Okay, maybe I'll start over here. And so my box will go from there to there. All right, and that's how high it will be. Highest and lowest point. Okay, so now we have to know what Q1, Q2, Q3 are from this data. So we already worked out, we're going to do for the birch tree. So we're looking at this data, which we already worked out for the birch trees, Q1, and we worked out Q3, I think. Okay, we have the lowest value, which is 28. We have the highest value, which is 85, and this is an outlier. So the highest value that's before the outliers, the highest value this is with the outlier, is going to be 76. So my whisker will go up to 76, and then 85 will be a point outside the whisker. We can go up to this limit. We could there's one method which you could use, take the whisker up to 84, because that was the limit. Okay, the limit was 84, and here the limit was 12. Okay, we could do that, but because I haven't done that for the maple trees, I'm going to keep to the same format for this. But both are normally acceptable in the mark schemes. So Q1, as we found earlier, was 39. And Q3 was 57. Right, we got to find what Q2 is. So let's find out what Q2 is. Q2, for the birch trees, we had, how many birch trees were there? We had 35 birch trees. Okay, so Q2 is going to be 35 divided by 2 is not equal to, that's just the position of it first. We'll find out what it's equal to when we worked out. That's telling us where it is, not what it is. So 35 over 2 is equal to, that's 17.5. So we're looking for the 18th term. Okay, 35 over 2, just in case I made a silly mistake. I'm sure that's correct, but sometimes I do silly things like that and then messes up the whole question. 35 divided by 2 is going to give us 17.5. So we round up to the next value. When it comes out as a decimal, we round up to the next value. We should understand when there's an odd number of entries, there will only be one number in the middle, which is the 18th term. So here we have 2, 10, and that will be 19. So the 18th term is this, which is 48. Okay, that's going to be the 18th term because we're looking at the birch trees, just right. So you see that's 2, then 10, 2, then 8, that's 10 terms, plus 9, 19, so 18, 48. Okay, 48 is the value of the median for the birch trees. So Q2 is equal to 48. So I'll put 48 here. So now what we have to do is you have to transfer this data onto the, stem and leaf diagram. So we got the lowest value. Let me draw the box first. So we got from 39 to 57. From 39 to 57. So let me just get a rectangle. You should do this with a pencil and a ruler. Make sure that it's neat. So 39 to 57. So we got 39, which is here. That's 39. We're going to go to 57. That's 55. Okay, that's 56, 57. I'm going to go 2 boxes down so that it's the same format as the one below. So try and be as accurate as possible. Okay, so there we have it, slightly lower than I try and fix that a little bit. Why is it not going? That's better. Okay, 39 to 57. Okay, so there we have the lower quartile, upper quartile, and then we need to put the median. The median is 48, so I have to draw a line at 48. Okay, so 48 is where? This is 45, 48 is here. So it's going to go from there down, from here down to there. Okay, that's 48. And then we have to do the whiskers. So the whiskers and the lower end go down to the lowest value, which is 28. So 28, we go down here to 28. That's 20, that's 30, so 2 more, that's 28. Now, because I haven't done it here, but sometimes you put like a little line going down where that ends, but here they didn't do it, so I'll just follow the same format that they used. And then we have the upper value is 76. That's the largest value within our range. That's not an outlier. So I'm going to go up to 76. Okay, so I'm going to go up to 76 with the other whisker on the higher end. That's 75. That's 70. That's 75. That's 76. Okay, I'm going to stop at 76. Let me just make it a bit slightly shorter. Yeah, that's 76. Just about right. And then you got to go up to 85. 85 is an outlier. So what I do for 85, I don't continue this. I just put like a little mark, then asterisk there to show that that's an outlier. Okay, there's no outliers on the low end. There's that one outlier on the upper end. So that is our box and whisker diagram, or the box plot for the heights that the birch trees grow in 1 year. So it's labeled already. I don't need to label it. And there we have the answer to part D. Okay, now part E. So part E says comment on any difference in the distributions of the growth of these birch trees and the growth of these maple trees. State the values of any statistics you have used to support your comment. Okay, so when we look at comparing box and whisker plots, we normally look at 2 things. One is the value of the median, which tells us about the average growth of, in this case, this is the growth per centimeter per year, sorry, growth in centimeters per year, right? So we can see that for the birch tree, we have a median Q2, which is equal to this value here, which is 48 as we calculated. And for the maple tree, the Q2 is equal to 45, right? So we can say that the median for the, let's make sure I don't make it mess up here, for the birch tree is greater than the median for the birch tree, okay, is 48, which is greater than the median for the maple tree, okay, which is 45. So we can say the average growth per year for the birch tree is slightly greater, just 3 centimeters per year. Okay, so we can mention that. So that's one thing that we can mention. All right, so on any difference in the distribution. So that's one thing we can mention. You would get the marks if you just mentioned that one thing. Now, if we were to compare the 2 things that we normally do compare is the position of the median and also the interquartile range. Now, if you look at the interquartile range of this, we have from 50, this is from 57 down to 39. So the interquartile range is 57 minus 39, which is 18. And here we have from 54 and down to 36, which is also 80. So if we compare the interquartile range, we would say that basically the spread of the data, the spread the spread of the growth per year is the same for both of them. Okay, the interquartile range tells you how spread out the data is, right? So you can say that the growth per year is kind of like consistent for both of them, same kind of consistency for both of them, right? But here they're asking us to highlight the differences. So I would stick with the median, because the median we see a slight difference. With the interquartile range, they're the same. That won't give any difference really for the interquartile range. But I guess you could maybe talk about the range. The range here, as we can see, is greater for the maple trees. If we ignore the outlier, okay, the range is greater for the maple trees than it is for the birch. We could mention that with the values, but I think the best thing here would be to mention the thing that is apparently different. Normally when we look at something like this, we don't normally look at the range. We normally look at the interquartile range because it takes out any extreme values. So we normally would look at the interquartile range, and here the interquartile range is basically the same in both of them. So I would compare the median myself. Okay, so that's what we do, but always put the values in. Okay, don't just do this without putting the values. You must put the values in, otherwise, especially here that mentions it, and you should mention about the growth per year. Don't just say the median is bigger for the birch tree. Explain what the median is. What the actual context of the question is. You should always write that. Right, so that's part E done. Now for part F. It says the researcher realized he has missed out 4 pieces of data for the maple trees. The heights each seedling grows in 1 year to the nearest centimeter in ascending order for these 4 maple trees that were missed out. 27 centimeters. So one of them goes in this region over here. Okay. And then 48 centimeters. So there's another piece of data that goes in this place over here. The 27 goes here. The 48 centimeters goes in this region here. So the 27 is before the first quartile. The 48 is above the second quartile and less than the upper quartile. So basically, you can say that 27 is less than Q1, and you can say 48 is between Q3 and Q2. All right. So for us to have this balanced out such that no change occurs to any of these, given that there's no change to box plots, find the range of possible values for A. So basically, if there's no change to the box plot whatsoever, okay, all those, extra pieces of data has to be balanced out. So one piece of data has to go in here, and one has to go in this region here. So A must be somewhere between the lower quartile and the median. So A has to be somewhere between 35 and 45. 36 and 45. It has to be somewhere between 36 and 45, and that will balance out, these two. And there must be something here. So 2A must be somewhere between. Now 2A has to be between this value here, which is going to be 54. Okay, but it can't be more than 80. It can't be more than 80. Why? Because if it's more than 80, then it will change the highest value in the data. The highest value in the data will now increase. Okay, and if there's outliers, whatever, it might become an outlier. It will change. The box plots will have a change to it. Either there will be an outlier, or this will be higher than it was in the, than it was in the original data. So it can't be. It must be less than 80. So if we think about this, combining these two together, then we can say that A, from the conditions for this is A has to be greater than or equal to 36 and less than or equal to 45. And according to this, if we take this and make it into A, divide by 2, this is going to be 27 is less than or equal to A, which is less than or equal to 40. So if we combine these two together, we got 36 is less than or equal to A, is less than or equal to 45. What is common between these two? What is the thing that we can accept between these two? It's A has to be between those two. Okay, so according to the first condition, A can be between 36 and 45. According to the second condition, A can be between 27 and 40. So what's like common between these two? It's between 36 and 40. So A must be greater than or equal to 36 and less than or equal to 40. Okay, so that combines both of them. Because if you think about between 27, which is here, so A can be between 27 and 40. 40 is over here. That's according to one of those conditions that we saw. Okay, one of those conditions we saw, it can be between those values. And for the other one, it can be between 36 and 45. So 36 and 45. So what's common between them? What's common between them is this region over here, where they overlap. Between 36 and 40. Okay, so this is the answer to the question. If A is between 36 and 40, then those conditions will be fulfilled. And you'll have one value in this section here. You'll have one value in this section here. You'll have these two values. All those values will be in the right place to balance out each other so that it doesn't make any change to the position of the median or the low quartile or the upper quartile, and it won't affect the highest value. So the box plot will look exactly the same. There'll be no change to the way the box plot looks. All the values will be the same as long as A is between these two values. Okay, that's what this question is showing. So that's the end of this question. Question number 1 from this paper. Other questions from this paper can be found in the playlist that will appear at the top right of the screen, the end of the video. Other questions from the topic of, I think this is data display and averages. I'll put data display and averages, different playlists here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.